Good day and welcome to our class on real analysis. In the last video, we looked at we defined the bounded sequence in terms of the lower bound and the upper bound. For today, we want to look at the absolute value definition of a bounded sequence, and then we'll try to prove it. What does the definition say? The absolute value definition. It says a sequence A sub n is bounded if and only if there exists a constant C contained in R such that what? The absolute value of A sub n is less than or equal to C. In this absolute value definition, we need not worry about the lower bound or the upper bound. Why? Because the C is greater than the absolute value of every term of the sequence. The C is greater than what? The absolute value of every term of the sequence. Let's look at the proof. But if we look at our definition, it makes use of what? If and only if. That means what? It is a two-way proof. It is a two-way proof. The first side of the proof is to show that if the sequence is bounded, if sequence A sub n is bounded, then what? The absolute value of A sub n will be less than or equal to C. Then the second side of the proof is to show that if the absolute value of A sub n is less than or equal to C, then the sequence is bounded. That's why I said it is a two-way proof. We are going to look at the first direction of the proof. The first direction of the proof, if sequence A sub n is bounded, then the absolute value of A sub n is less than or equal to C. How do we prove that? Since we are assuming A sub n to be bounded, we say let sequence A sub n to be a bounded sequence. Let sequence A sub n to be what? A bounded sequence. And if it is a bounded sequence, what does that imply for us? From our definition, using the lower bound and the upper bound, it implies that what? You want to recall the definition of bounded sequence. You mean the definition involving lower bound and upper bound. It says if L is contained in R and U is also contained in R, where L is a lower bound and U is an upper bound, then the sequence is bounded if L is less than or equal to A sub n less than or equal to U. The sequence will be bounded. If L and U are less than 0, L less than 0, u less than 0. What does that imply? L and u are negative. If they are negative, then it means that what? Our L is at least as negative as u. L is at least as negative as u. And since we cannot get an upper bound that is more negative than the lower bound, what do we do? When L and U are negative, the appropriate upper bound will then be what? The absolute value of L. When L, therefore, when L and U are negative, the upper bound is the absolute value of L. On the other hand, if L is greater than 0 and U greater than 0, which implies that L and U are positive, an appropriate upper bound will be what? Will be our U. If L and U are positive, as we have here, therefore, an appropriate upper bound is U. Now let's see be the maximum of the absolute value of L and our U. If C is the maximum of that, we want to show that the absolute value of A sub n is less than or equal to C. Or we want to show that our C is greater than the absolute value of A sub n, which is the same thing as saying that what? Absolute value of A sub n is less than or equal to C. And if that is the case, what does that imply for us? If the absolute value of A sub n is less than or equal to C, by our equivalence, it implies that what? Minus C is less than or equal to A sub n less than or equal to C. And from the definition of bounded sequence that we gave there, it means our L is less than or equal to A sub n less than or equal to U. Therefore, our A sub n is less than or equal to U. But C is the maximum of the absolute value of L and U. Therefore, if the absolute value of A sub n is less than or equal to U, it means it is also what? Less than or equal to C. That implies that absolute value of A sub n is less than or equal to C. Also, if L is less than or equal to A sub n, then that means that our L is greater than or equal to the minus of its absolute value. Therefore, the minus of absolute value of L will be less than or equal to L, and L is less than or equal to what? A sub n. But we have said let C be the maximum of the absolute value of L and U. Therefore, the minus of absolute value of L will be greater than or equal to our minus C. And that means that minus C is less than or equal to the absolute value minus the absolute value of L. And so we can say that minus C is less than or equal to minus absolute value of L, which is less than or equal to our L, and that is also less than or equal to our A sub N. So this is what we are going to try to do. We will try to match up the two together. We will match up this. We want to match it with that. So what would that give us? It gives us minus C less than or equal to minus the absolute value of L, less than or equal to L, less than or equal to A sub N, and our A sub N is less than or equal to U, which is less than or equal to C. And we can do away with all the other things inside and leave the C. This leaves us with what? Minus C less than or equal to A sub N less than or equal to C. And therefore, remember the equivalence rule. This implies that our what? The absolute value of A sub N is less than or equal to C. Therefore, if the sequence is bounded, then absolute value of A sub N is less than or equal to C. That's the first direction of the proof. We will now go ahead to prove the second direction. And what does the second direction say? It says if the absolute value of A sub N is less than or equal to C, then what? Then the sequence is bounded. The second direction of the proof. What does the second direction say? If the absolute value of A sub N is less than or equal to C, then the sequence A sub N is bounded. The sequence A sub N is bounded. So again, to prove that, let the absolute value of A sub N be less than or equal to C. Remember when we wanted to prove the first direction, we said let the sequence be bounded. And then we used the definition of bounded sequence having lower bound and upper bound until we got to that point. But in this case now, we want to start with let the absolute value of A sub N be less than or equal to C. If that is true, therefore, by equivalence, minus C will be less than or equal to A sub N less than or equal to C. This means that what? Our minus C is a lower bound and C is an upper bound. When we compare this with the definition of bounded sequence, which says that L is less than or equal to A sub N less than or equal to U. For every term of the sequence which lies between L, the lower bound, and U, the upper bound, for a bounded sequence, will do what? Will lie between minus C and C. And if it does lie between minus C and C, therefore the sequence is bounded. Therefore the sequence is bounded. As such, we have been able to prove the second direction, that if the absolute value of a sub n is less than or equal to C, then the sequence is bounded. We can now conclude that what? A sequence a sub n is bounded if and only if there exists a C contained in R such that the absolute value of a sub n is less than or equal to C for all n in the set of natural number. We can conclude that a sequence a sub n is bounded if and only if there exists a C contained in the set of real numbers such that what? The absolute value of a sub n is less than or equal to C for all n contained in the set of natural number. And that is the proof. Remember once again that I said the proof for this absolute value definition of bounded sequence is in what? Is in two directions. The first direction is to show that if the sequence is bounded, then what? Then the absolute value of a sub n will be less than or equal to C. And we make the assumption that the sequence is bounded. And from there, we show that absolute value of a sub n is less than or equal to C. Then the second direction is what we have here, where we assume that the absolute value of a sub n is less than or equal to C. And from there, we prove that it is bounded. And so if we are able to prove the two directions, we can then conclude that a sequence is bounded if and only if there exists a C in R such that the absolute value of a sub n is less than or equal to C for all n contained in capital N. Thank you for watching thus far. If you have gained anything from the video, give it a thumbs up, like it, and share with your friends and colleagues so that they too can benefit. Thank you. God bless you. I see you in the next video.